Hi, Owen. Hi, Skylar.
How's it going?
Things are going good. What about you, Owen? I see you're in San Francisco today.
You look like you're enjoying the forest there with some water.
Okay. I'm just setting up the other thing. A bit of luck. Looks like wrong way around. It's better. It's a weird angle. No, what about that? Keelan and Gascoigne. That's cool. Still have about 5 minutes. Might as well use this time. Has anybody got some questions, just general stuff that you want to talk about? Anything you're not sure about?
Moment. We haven't really got too busy this week, so.
Okay. Well, we'll go over some stuff that might help you when you do come to them.
Gotcha.
Anybody get any questions to do with when the test is or anything specific?
I have a question about one of the homework problems.
Okay, what section's that in? Do you know?
It was in the
Hold on a second. Right. I'm just muting everybody. There's a lot of feedback coming. Probably will get very annoying if you hear me. Now you hear an echo of me as well. So, who was it that had the question again before I muted you all? Was it you, Owen? Right, so I'm going to unmute you. Okay, what were you saying? What section?
It was 6.6, and it was question 8.
8, okay.
And I could always just post it in the text chat.
No, I got the question here. We'll probably use that then as one of our examples that we'll go over today. I mean, I guarantee if you've got a problem, there'll be others who'll benefit from it. So that's totally fine. Right. Olivia, you had an email from me. I hope you've done something about it.
Which email was that?
We can talk about that at the end.
Okay. All right.
Okay, we still got some people coming in. Still got a few minutes to wait.
Oh, could I ask for a certain problem to be done?
Oscar.
I'm sorry?
I can't hear you quite. You're cutting off at the end.
I'm just asking if I can ask for a certain problem to be done.
Sure. Which one?
Yeah. 6.4, number 21.
Okay, I got that.
All right.
That's actually one I wanted done too.
So I will do it twice. No, I won't. I'll only do it once.
I also had a question about the test.
Mhm.
Is it the one on WebAssign or is it on Canvas?
It's going to be on WebAssign, but you can't see it yet. You won't be able to see it until Sunday morning, and then it will appear, and you'll be able to see it then. So that thing that you're looking at, I think, is just a quiz. It's just like a practice getting you ready for the test. But the test will be on all of Chapter 6, not just those sections.
Okay,
How we
thank
doing?
you.
Right. How are we doing, Ashley? Well, I could see you mouthing fine, but I couldn't hear you saying fine. So I'm assuming. Oh, there you go.
Yeah, I'm okay.
Life is good.
Life is life.
God, you're depressing.
Sorry.
Okay, we've got Conrad coming in. I'll be starting shortly. Yeah, okay. Anyone else? Looks like we're good. Okay, so before we get started on the going over some homework questions, because I think that'd be probably a good use of our time. While we're all kind of here, let me show you some things. First things first, class view, no, dashboard, yes. Can you see the dashboard? Can you see Canvas dashboard right now?
No.
No, okay, so I have to do this funny thing. It's quite strange, but it's the way it works. I have to go in and then out. Why, I don't know. Let me try it again. Here we go. Right, you can see it now. Agreed? You can see Canvas.
Yes.
Good. Okay,
Yes,
so
I do.
right, here goes. I'm picking this. Your voice is not coming through clearly. Actually, it's me that's coming through. That's not good. Hold on a second. Okay, let's get back in. That should have cleared up the feedback. Right, we got this guy here. I'm picking this one, but it could be any of your classes. What I want to show you here is a couple of things that you'll probably want. On Sunday, you can't see it yet, but on Sunday morning, the test will appear. And you will do the test in WebAssign, just like we do homework. And the rules for the test are much more severe. You only get one shot at each question, and you won't know if you're right or wrong. So be careful. Do working for this test, because I do want to see the working. So sometime on Sunday, you're going to decide that it's your time, you're ready to do the test. So you'll click on the test, and the minute you click on the test, you've got 2.5 hours to do it. So don't click on it out of curiosity, because the minute you do that, the clock starts. Once you've finished the test, you can then take copies of it using your camera, take pictures of it and turn them into PDFs. There's a program down here called How to Get Cam Scanner. That's a program that will let you do that. So whoever that was actually, right? So this is Cam Scanner. You're able to do that. You can use other things as long as I get it into PDF. So you've done the test, you've got your working, you've taken pictures, turned it into a PDF file. You're going to click on this guy. And this guy is a video that basically tells you how to upload your working into Canvas. So your test is going to be in WebAssign, but your working is going to appear separately as a PDF and uploaded to Canvas. So I'll do a quick hit on this thing and zoom to, I think it's about here. Yeah, So what you're going to do is, this is what your screen will look like. You're going to hit submit assignment. And when you hit submit assignment, this thing moves long enough. Come on, there we go. You'll then get this window. You're going to file upload, choose file. This will be on your computer. Open it. And then when you're really happy, submit assignments. And if you have to make alterations, the video tells you how you can upload it again, resubmit it. Okay, so hopefully that covers what you need to do to upload your file, which is your working file. Now, let's jump, if there's, excuse me. I have 2 more people who've just turned up, I think, is it? No, I've got a chat too. What's the chat say? I'm not sure what that is, but evidently it's a comment that I really don't need to worry about. So, right, let's see if we can get into this picture. Are you all now looking at the picture that is basically your homework site? We good? Yeah. So the first question I had was, although I'll do it in the order that they, not that were given, but the order that they work in the homework, we'll click on this guy. And the question that we're going to be doing is, I believe, question 8. So let's see. This is my question 8. Is that the one you're talking about, or is it a different one than that? Could someone just say something so I can check that I haven't permanently muted you? Just say hi or something so I know if it's working.
Yeah, it's good.
Oh, we're good. Okay, so whoever asked that question, before I continue, is that the one that you want to get the answer to? I've written down here 6-4, and it wasn't that one. It was question 20 something. So the answer is no, that wasn't. This is the one you asked for, wasn't it? This guy.
Nothing's showing up on the screen.
Ah, that's a different problem. Okay. Stop sharing. Reshare. So weird thing that I haven't figured out if there's a shortcut that I'm just missing. Are you seeing it now? You seeing question 21 at the top?
Yes.
Right, okay. Tell me with that when I do it in the future, because I see on my screen, but I don't know that you're seeing what I see on my screen, and sometimes it doesn't work. So I'm just going to write this question down, and then I'm going to switch over to my written fella and use him. So stop sharing that one. Here's my guy. And right. Are you now looking at a big version of that piece of paper with my hand?
Yes.
Right, okay. Now, this question says something like express this or rewrite this as an expression in terms of x. I think that's how it's phrased. First thing I'm going to do is I'm going to isolate this fella. And if somebody says to you, what are you finding when you find the inverse tan of anything, like the inverse tan of 2 or 0.5, what you're finding is an angle whose tan is equal to x. So this is an angle. I don't know what that angle is, so I'm going to call it theta. Now, if you take the inverse tan of x equals theta, you can also rewrite it and say that it's the same information as the x is the tan of theta, right? So the inverse tan of x equals theta is the same thing as saying x is the tan of theta. We cool with that? Essentially what I've done is find the tan of both sides, and the tan of an inverse tan cancels out. Right. So we're at this point. Now I'm going to do something that seems pointless, but it isn't. I'm going to write the x as x over 1. Not particularly helpful, but here goes. According to SOHCAHTOA, isn't the tangent the opposite over the adjacent? And isn't the tangent, according to this, x over 1? So that makes x over 1 the opposite over the adjacent. And you might be thinking, I wonder what good that is. Well, I'm now going to construct a right angle triangle. I'm going to make this angle here theta. So that's going to be opposite. That's going to be adjacent. And this guy is going to be the hypotenuse. And the opposite is x. And the adjacent is 1. So I can now replace the opposite with x and the adjacent with the number 1. And now I'm going to figure out how to get the hypotenuse. Now, if that was 4 and that was 1, wouldn't I just use Pythagoras and I'd get the square root of 17? Right? If that was 2 and that was 1, I'd use Pythagoras and eventually I'd get the square root of 5. Well, according to Pythagoras, you square this guy, you square this guy, add them together and then take the square root. So the hypotenuse is x squared, the square root of x squared plus 1. Now go back to the original question. I'm being asked to find the sine of the inverse tan of x. But I know that that's the same thing as finding the sine of theta. And I know that because I decided that theta was that guy. But the sine of theta is opposite over hypotenuse. So the sine of theta is x over the square root of x squared plus 1. And we are finished. That's what they were looking for. That make any questions about that? Anything you're not sure about why I did what I did? Call that good? Okay. Right, the next homework question, so we're jumping around a little bit, that's nothing wrong with that, is going to be in section 6.6, number 8. So I'm assuming that's going to be the cosine rule. So I need to do some things here. I need to go around. Here we go. That's right. That's fine. Now I'm going to go into screen share. I'm going to click this. I'm going to close this one off. Okay. I'm going into screen share. I'm going to click on this. And we're going to go to 6.6, question 8. Okay, let's go out and in because that's probably what I'm going to have to do anyway. Okay, after all that out and in and back again, with a bit of luck, when I go in this time, you should see that question. Is that the question you were talking about at the top there?
Yes, it is.
Okay, so I will draw a picture of this thing. And we have two sides. It's a bit like a funny kind of stealth bomber kind of wing. The numbers I've got are 4, 6, and Y is 70 degrees. You may have a different one. And you're being asked here to find the area A. Okay, now that I know what we're being asked to do, I'm going to stop that. And okay, where's my guy? That's an idea. In a few seconds from now, you should see Spotlight video. There we go. So I want to find the area of this shape. I'm going to put some numbers into the picture now. Probably should have done that at the start. This guy's 4, this guy's 4, this guy's 7, this guy's 7, and this angle in here is 70 degrees. Right, so far so good. Now I'm going to add an invisible line. Now this shape, I'm making the assumption that I think is valid, is very symmetric. Would you agree that that line where the pen is an axis of symmetry? In other words, the two little baby triangles are the same size and shape as each other. So that's a reasonable assumption. Right. So what I'm going to do instead is I'm going to find the area of this guy, or that one, and just double it. Right. So this is going to be 2 times the area of one triangle, right? So far, so good. Right. So if you look at this shaded triangle here, this guy's 4, don't know that guy. Then it kind of goes up some like this. And this angle here is 35 degrees. And this is 7. So far, so good. Now, these are one of these puzzle questions, what I would call a puzzle question, whereas there is enough information there to get the area of that triangle, but the numbers that you've got in front of you right now are not the ones that you need. There's a formula for getting the area of a triangle, and it's called something like a half AB sine C. Now, if you want to find the area of a triangle using this formula, you need to know 2 sides and the angle between them. Any 2 sides and the angle between them will do, but you need, that's what you need. Now, when I look at this triangle, I've got an angle and I've got this side. What I don't have is that guy, which I'm going to call X, I guess, for a minute. If I can find out what that guy is, won't the answer be a half times X times 7 times the sine of 35, and that will be this guy? And then I'll just double it and I'll get that guy. You see, that's the logic of how I'm going to approach this question, right? I'm going to find this distance so I can use this formula to get the area of one triangle, and then going to double that answer to get the area of the whole shape. So, back to this fella now. I'm going to call this guy A, I'm going to call this guy B, I'm going to call this guy C. I'm going to use the law of sines. Now, I know angle A. I know this guy who's little a. I know, excuse me for a minute, I know B. No, I don't, sorry. Take that back. I know C. Agreed? But what I don't know is this guy here, which I guess I shouldn't call X anymore. I should call him B. So I'm going to try and eventually somehow get B, because once I get B, then I can use this, and then I double it to get that. So it's one of those A to B to C to D to E kind of steps, right? It's not a one clean, here's 2 numbers and do what you need. Well, let's see. Since I know that much, I can put them together and get the sine of A over little a is going to be the sine of C over little c. I'm going to start a new piece of paper and then I can come back to that. So on my triangle, it would look something like this. we now have the sine of A over little a, sine of C over little c. That's the sine of 35 degrees over 4 is equal to the sine of C over 7. A little cross multiply. 4 times the sine of C is 7 times that guy. The sine of C is 7 times the sine of 35, all divided by 4. Okay, now I need some help from someone here. If you can make sure your calculator is in degrees, do 7 times the sine of 35 and then divide the answer by 4. And it's probably a good idea to put a bracket around the top just to be sure. So could someone tell me what the decimal value of that is? And that'll help us move on. Has anyone got a calculator to do that? I would have assumed that someone did.
It's 1.00.
Oh, no, don't give me 1 point, please. That's
Oh.
bad news. Oh, because if that's the case, this question is impossible.
Oh, I forgot the bracket. Just kidding.
Ah,
Put it in
good.
the chat.
Right. If you put in the bracket, what do you get? 0 point. Help me here. I do not have my calculator handy. Okay, here goes. I'll use an online thing.
Yeah, I'm getting the same 1.003.
Okay, so I have a 7 and a 4 and a 35 degrees. That is interesting. Ooh. Let me just one last try. Put a bracket around it. I'm going to go 7 times sine of 35. Okay. No, it's not going to work. Okay, can you just tell me what the sine of 35 is?
Zero 0.573576.
573. Thank you.
Yeah.
So we got that guy. I'm going to multiply him by 7. And then I'm going to divide by... That can't be right. So 0 point... Did you say 537?
0.573.
073. Okay. So 0. I keep coming up with a weird answer. 0 0.537. I'm going to write this down next time.
It's 0.5735.
Okay. Hold on a moment. 0.573 will do. The thing I'm using is the calculator on the computer, and it is totally useless for doing anything. At least it is for my poor brain. Because I think you have to make sure that you cancel previous entries, or it just uses numbers from the previous answer. I still get a number that's bigger than 1.
Same.
Right. Okay. There's one last thing I'm going to try before I scream prophetically at this darn computer. We have 35 degrees. We're going to do an inverse sine on it.
At one point, a 6 got turned into a 7.
Yeah,
Cool.
that's better shade right now.
Was that just me transferring somehow?
Yeah.
Oh, that is probably it. Well caught. Okay. New question, better numbers. 6 times the sine of 35 divided by 4. What do you get?
0.86.
See how easy it is when you use the right numbers? Okay, so C is going to be the inverse sine of 0.86. Okay, what angle gives you that? Inverse sine of 0.86.
What was the question again?
The inverse sine of 0.86.
59.3.
Now, there may be some discrepancies caused by rounding off, but that number seems reasonable. And during all that hassle, one number, a 6 becoming a 7, screwed up the process. So you might have said, how did I know it was screwed up? Because it could have been, you know, a normal number and we just would have kept on going. You cannot get a sine bigger than 1. And I kept on doing it. I'm saying, that's still bigger than 1. I must have hit something wrong. You know, the sine only has values that range between 1 and -1, right? That's the biggest and smallest it can be. Now, back to this question. We now know this fella. So to remind you how we were going to do it, the area of the triangle is a half AB sine C, or there's 3 versions of it. It depends on what ones have I not got right. Right. I tend to look at this formula as simply just being, skipped ahead. We have only found 59.3 degrees. Don't we still need to get B? And the reason that we need to get B is because I need to be able to get that guy. And that's the guy that was kind of causing, well, actually, take that back. Take that back. Let's find angle B first. I know angle A is 35 degrees. I know angle B is 59.3 degrees, or I should say angle C. So how will I find angle B?
You can just take 180 and subtract those two.
Yeah, so I'm not going to risk my brain here. That's a 0.3. Add them. 4 carry 1. 9. I make it 94.3. So what's left is 85.7. Seems reasonable. Okay. So if I draw yet another version of this poor picture, we know this is 4, we know this is 6, and this guy up here is 85.7. So what I'm saying is, look, I got 2 sides in an angle. I can now get the area. It's going to be a half 4 times 6 times the sine of 85.7. That's basically a half AB sine C kind of question. Right, so to finish this piece of the puzzle, what does this end up getting?
Sorry, I'm lost. I thought it was 94.3. How's it 85.7? I guess I missed that.
94.3 is what these two add up to, but the piece that's missing is 85.7. Right, the 3 of them together add up to 180. So 2 of them add up to this. What's left is that one. That's what I was saying. Right, have we got a half times 4 times 6 times sine of 85.7, Andy?
11.96.
Okay,
97.
Yeah, I'm going to call that 12 because the amount of rounding off we've been doing today, it probably is 12. Well, after all that hard work, let's return back to the question. We have just found out that that has an area of 12. Isn't this shape made up of two of them? So to the nearest whole number, 24 square inches. Which brings me to, if this had been a test question, do you see that there's a fair amount of working that would be in that? And it might be worth 4 or 5 points, probably 4. And if I'd screwed up at any point along this with a number that turned into a 7 that should have been a 6, or, you know, I can't add, which is true, I can't, and I put in 98 when I should have called it 88. You know, those kind of little mistakes that you make along the road. If I'd seen your working, I would went and said, okay, that guy's worth 4. Pretty much you did it right, or she did it right. You'll get 384. On the other hand, if you do that question in the computer, don't you just get wrong? You get a 0. And so if you're wondering, you know, why should I put all this effort into showing my working? And that's a great example of why it can get you a lot more points than if you just, you know, trust the computer and if you get it wrong. And the computer won't even tell you you're wrong. It will just take your answer and you'll think none, you know, oh, I probably got it right, and you won't even know. Okay, we got time for another question. Anybody got a question?
For the test, am I okay to use an iPad and just scan on that, or do I have to use regular paper?
You can, for working, I don't care what technology you're using as long as it turns into a PDF when you're finished. Some of you, for instance, are lucky enough to have a printer. You know, if you've got a printer and it's got a scan feature, you just make sure you put it in good paper and it's all crinkled. You can feed it through that and it'll take all your work and turn it into a PDF as well. The CAM scanner is pretty much for everyone else. Basically, you just take your camera, you take a picture of it, and then the next page, picture, next page, picture. If there's 4 or 5 pages, the software will turn them into PDFs and put them into one file for you, and then you're pretty much good to go. And I think, I've not tried it because I don't need to. If you use your phone to go into Canvas, I know it's not the biggest picture in the world, but can you use that, or do you have to send it from your phone to to your computer before you can do it? Can you I guess I'm asking, can you upload files from your phone to Canvas without too much trouble?
I believe so.
Yeah, well, I guess you're going to find out. And if you don't want to worry about finding out, why don't you just take a picture of nothing particular and go to that place and try and upload something just to see if it works on your phone. And you'll know the minute you try whether it's going to work or not. And if it doesn't, then since it's on your phone, but you probably need your computer, let's say you do need your computer, like your PC, you know, you can send yourself the file as an attachment, and then you can upload it by sending it to yourself and then putting it on your desktop. Okay, while we're pausing, what's our next question going to look like?
A question in the chat asked how many questions are on the test.
Oh, thanks for doing that. I'm not very observant, as my wife will tell you. I don't know. I believe it's 20 something. I still don't know. I know it's written and I know it's ready to go, but I can't remember. I do remember you get 250 minutes, and when I was looking at it, I was thinking you could probably do it in 2 hours, but I decided just to add another half hour in case, you know, something weird went on. When you've been doing the questions, do you know that one that I screwed up on, where the 6 turned into a 7 and it didn't work? Have you got homework questions where it is possible for the triangle not to work, in which case the answer is doesn't exist? Has that happened in any question? Nobody's came across that. At least in the homework, if it doesn't exist, I believe you type DNA. It'll say check, you're right. So you'll know if that was the case. Right, am I going to pick the next question, or has someone got something that might be more suitable to them? I want to make this time, valuable for the people that are here.
Can we do 6.5, number 5?
Let's have a look. Okay, I'm going to have to do that out and in, carry on. So bear with me. 6.5, number 5. So we're in the law of sines. And question 5 is this one. And so I'm going to go out. Then I'm going to go back in. Is it this guy at the top you're talking about?
Yeah, that's the one.
Right, so let's see what it says. Use the law of sines to solve for all possible triangles that satisfy these conditions. And they're giving you A is 28, little a is 28, little c is 48, and finally angle A is 25 degrees. Right, this looks like it's one of those questions where there may be two triangles. So can you imagine one of these is 50 and the other's 130? I suspect that might be what they're going to do here. Let's find out, in fact, if that's what happened. So I'll click on this fella again, spotlight the video. When you do these questions, you really do need to do a picture. I don't see any advantages in not doing it. So I have a triangle. I'll call this A, I'll call this B, I'll call this C, make them placeholders. This is little a, this is little b, this is little c. Little a is 28, little c is 48, and angle A is 25 degrees. So that's our starting point. I'll then set up the law of sines. Typically, I do the check mark trick. So I say, okay, I know angle A, check. I know little a, check. I know little c, check. So it's pretty clear to me that I'm going to use the A and the C. And what that will do is it will allow me to get angle C. So that's my first quest, angle C coming up. So sine A over little a, sine C over little c. And angle A is 25 degrees, divided by the number 28 is the sine of angle C divided by the number 48. If you do a cross multiply, 28 sine C is 48 times the sine of 25 degrees. And so the sine of C is 48 times the sine of 25 degrees. Put a bracket around it, divided by 28. Okay, so here is, fingers crossed and nothing weird happens, what does the sine of 48 times the sine of 25 divided by 28 give me? And it better be a 0 point something.
0.724.
Okay, that sounds good. So to get C, it's going to be the inverse sine of 0.724. And we're going to get an angle for C in a moment now.
46.4.
I didn't catch the first digit.
46.4.
Okay. Are we getting agreement on that? Just so we can continue. We're getting nods, that is a good sign. Now, if I go back up here and I put in 46.4, I now have a triangle where I can get the third angle, because that one plus that one, whatever's left goes there. So let's see what that looks like. If you take 25 and add 46.4 to it, these two fellas add up to 71.4, which means this missing angle here, that's going to be whatever's left. So what's left? 180, take away 71.4, that gives me 108.6 degrees. And I'm not finished, but I'm kind of finished with this question up to this point. Now that I know that angle and I know those two sides, can't I just do sine roll and get a bit more, and eventually I'll get B? Right. So we'll pretend I've done that. But let's look now back at this guy. He is correct, and he is definitely one of the answers. But this question is all possible triangles. So let's look at an alternate version of this guy. If this guy is 46.1, the other possibility, the one in the second quadrant, it's called a supplementary angle, if you want to look up a name for it. The other choice in the second quadrant is a 133.6 degrees. Now you may say, where does that come from? These two guys always add up to 180. So whatever this one is, right, take it away from 180, you've now got to, hopefully I counted right, you got 133.6. Well, if I go back to my triangle, one that looked like this, with the A, which was 25 in it, right? And the C here and the B here. If I now tell you that this angle is 133.6, is that angle possible based on the information that's here? And the answer is yes. This angle and this angle can work because they add up to less than 180. And if you add these two guys together, you get 58.6. If you take that away from 180, you get 21.4 degrees, which makes that angle in there 21.4 degrees. This is little a, this is little b, and this is little c. So do you see that what we have, in fact, are two different triangles that fitted the original information? Now, they may look the same, but the numbers are totally different, right? So that can happen, and that's why that question was phrased that way. So I believe at the top of the question they had, you know, angle C1 and angle C2. So can you imagine that this here was all the C1s, B1s, and so on, and that this triangle here would be for all the C2s, B2s, and A2s, and so on. So two distinct answers. I didn't finish these questions, but the gist of what you need to finish them is there. We fine?
Thank you.
You're welcome. Okay, where are we off to next for probably our last question, because I have another meeting after this. And that takes time to set it all up and so on and so forth. So what you got for your last one?
Wait, where'd you get the 180 from? Like when you were,
This one?
yeah. Well, like
Right.
why would you use 180 to get to
Okay.
Yes.
There's a property of triangles that says all three angles add up to 180.
Yeah.
So if I know this is 46 and a bit and this is 25 and a bit, you add them up and you get 71 and a bit. And since they add up to 180, if I know what two of them is, taking it away from 180 is what the third one has to be equal to, so that all three together make 180.
But I'm talking about when you made like the second try, when you got like
Oh, okay, that's a different property. So let me show you that one.
what property is that one?
It's a property to do with the sine function. So can you imagine in in quadrant 1, let's make that 40 degrees, make the calculations easier. One of the angles you got was 40 degrees. Right?
Yeah.
And you want to know who the other guy is. The other guy is over here in the second quadrant, because there's 2 places where an angle can be equal to, the sine of an angle can be equal to something, right?
Yeah.
Now, the symmetry is that this angle here is the same size as that. So if I know this is 40, how do I get this guy? Well, you just say 180 take away 40. So if I know one of the angles is 22 degrees, the other one will be 158 degrees. So in the question that you were talking about, that guy is 46.4.
Yeah.
Take that away from 180, and that's the other guy that could be equal to him. So 180 take away that is where he came from. And the second angle is always going to be 180 take away the first one that you get from your calculator.
All right.
Okay, and you can look into the theory of it, but I could show you in a unit circle. Right, there's 30 degrees. What's the sine of 30 degrees? What's its coordinates? Can you remember?
No.
Okay.
Wait. Is it the square root of 3/2? Oh, 1. All right. That's okay.
It's that one, right? Now, isn't it the y coordinate? By the way, the y coordinate is the sine, right?
Yeah.
So in this case, it's a half. Isn't there another guy over here whose y coordinate is a half as well?
Yeah.
Now, this guy over here, do you know what his size is?
That's like 150.
Yeah. Now, do you notice that those two numbers have something very common? Aren't both of them adding up to 180?
Oh.
So
no.
if I tell you the one in the first quadrant's 22, can't you figure out who the other one is? It's what's left from 180 when you take 22 away from it. That's what I'm doing. Right?
Wouldn't you why would that be like the same thing and not like a negative number?
Well, if you look at it, it's the y coordinate,
Okay.
and the y coordinates are positive in the first and second quadrants, and the y coordinate is where the sine works. You don't have this issue in the cosine rule, which is great, because when you do the cosine rule, the one angle you get is the only angle you need to worry about. There isn't another choice. Right? So this little, sometimes there's 2 answers, right, in the sine rule, is only a sine rule issue. When it's a cosine rule, when it's SOHCAHTOA, thankfully, as well, they're only one answer, right? In a right angle triangle, the inverse sine, whatever it is, 42 is it. Right angle triangle, one choice. Cosine rule ends up being only one choice, right? But for the sine rule, there could be 2 choices.
Okay. Because I had trouble with one of the questions in 6.4 with that. Or I don't know. Never mind.
Well, unfortunately, we've kind of came to the end of this time period. I have, as I say, I've got another Zoom lesson straight after this one, so I have to close this one out and set up the other one and all that good stuff. So any other questions, shoot me an email. If it's something I have to do visually, we'll do a Zoom. Only one person should stay behind if he's around. Sorry, if she's around. Olivia, are you in here somewhere? I lost you. Okay.
No, I'm here.
There you are. Yeah. Okay. So if everybody else can go bye-bye, I need to talk to Olivia just for a few seconds, and then I'll be off to my next meeting. So have a nice weekend, but not too nice a weekend, because you have to study for your big test. Okay, Olivia, I sent you an email. Was basically, as far as I know, maybe you can tell me I'm wrong. That would be nice if you could show me that you haven't been doing any of the assignments, or virtually none of the assignments. Is that that's the problem? Because if you don't, I'm going to have to. Basically, you're not going to pass. So I'll have to drop you from the class for essentially non-attendance. So what's going to happen with this? Are you going to start getting your act together and get ready for this test and do all the work between now and then, so I don't end up having to drop you?
Yes, of course. I did an entire assignment today.
Great. I haven't looked today, so I don't know.
Mm.
You know, I didn't know that. But great. Get everything you possibly can, because at the end of each week, the door closes and you can't go back and catch up.
Mm-hmm.
And you got to do that. So I'm glad to hear you're going to be working on that, and I look forward to seeing all those good grades from now on.
Of course.
Okay. Well, bye bye then.
All
I'll
right.
see you soon.
See you next week. Yep.